This video has been made to give the idea of what we can do simply using the terminal. One very time-consuming part is building the tennis court with the hash. In this video, we are using timers of 1 second after winning a point and 150 milliseconds after every move of the ball to stabilize the terminal. In this tennis simulation, the player who fails to keep the ball in their court loses the point. Thus, if Rafa Nadal serves, the ball appears in a corner of his court and begins to move randomly with a range of plus or minus 1 and 0 in the horizontal and vertical directions of the court. Who serves and the service area is decided by a random number between 1 and 4. This game is completely random, but follows the rules of tennis, and we can keep score of points, games, and sets as in real tennis. This program is based in a football video game that we did before. We use a function called printBoard to print the matrix with dimension 29 by 13 that create the court. With a function called moveBall, we search the ball in the previous matrix and calculate the next movement.
Cool.
This function also knows if the ball is out of the court and the point has a winner. The control of the points counter, games and set is done with an instantiable class that was done by Copilot, but modified by myself to control total points and the way to handle either game at deuce and advantage in the points. To follow the action, we have programmed a timer with 1 second after every point win and 150 milliseconds after every point in order to stabilize the terminal graphics. This is the best setting to see and follow the video. Adding the longest point of the match turned out to be a very good decision and improves the data visualization significantly. Also, we add all the information to a file that we can analyze properly later. At the end of the tennis match, we can see the heat map. We have 5 colors from green to red in order to see the position reached the most by the ball. Red color is more than 30 times, purple more than 20, yellow more than 10, and green between 0 and 10. We can see zone in red is the most reached by the ball. This position is around the serve position. Once we have the program finished as we want, then we can program ball movements as real trajectories, straight and sideways. This is the idea for the next game evolution. We can see zone in red is the most reached by the ball. This position is around the serve position. Once we have the program finished as we want, then we can program ball movements as real trajectories, straight and sideways. This is the idea for the next game evolution.